All right, welcome to our guide to area about parallelograms and triangles. Let me do a quick apology. I'm actually speaking of area, at area 51, so hopefully if you happen to see any strange things that won't distract the learning process. Anyway, I hope you're already familiar with squares and rectangles with respect to area. The area of a rectangle is base. We're going to talk about that word base here in the upcoming days, but base times height, or length times width is another common thing. And then, of course, a square has the same length and the same width, so it's just a side times a side squares. The base and the height are the same. So let's jump straight into our example here. If the area of a square is 9 centimeters squared, then what is its perimeter? Well, if the side squared is equal to 9 centimeters, we can take the square root of both sides. Square root of 9 is 3, so each of those sides is 3. What's the perimeter then? 12. So that's an example of how to do this. There's 4 threes, of course, with that square. Example B, we have to do a little bit more figuring here. If the perimeter of a rectangle is 20 centimeters, so the perimeter of all 4 of these sides added together is 20. If its height is 4, that happens on both sides of the rectangle. Well, what does that leave? 20, take away the 2 4s, 20 take away 8, it leaves us with 12. So, or we could just put the B for base, base plus 4 plus 4 equals 20 and solve. Either which way you get there, we get the length or the base of this rectangle is 24. So the area is the base times the height, the length times the width. 6 times 4 is 24 unit squares. Please be careful, always when you're given an area, put the squared for the units with it. So squares and rectangles are the simplest creatures with respect to area. Go ahead and see if you can fill out this chart. If these are all rectangles, numbers 1 through 8, if the base and the height are 8 and 7, what's the area? If the area is 60 and the base is 15, what's the height, etc. Go ahead and see, pause the video so you can fill in that chart. Okay, here are some answers. Now, these questions here were really just about the expressions. If the base is 3x and this is x minus 1, the product of those two things, and can you multiply y plus 1 and y minus 2 together? You don't get well, it's in terms of y there for those last few of them. All right, then we get some questions. These are totally related to what we've done in previous sections as well. When we're talking about, well, I'm getting ahead of myself, sorry, but more word type problems here in 9 through 12. See if you can handle those. Okay, here are the answers. We'll talk about it in class next time if you got questions, but hopefully we did okay. So this one involves area and perimeter, like my example B up there. So if the base and the height are here, what is the area, what's the perimeter? Here, if it gives you the base is 22 and the perimeter is this is exactly like my example B up there. You'll solve. So a little bit of problem solving here on this chart. Pause the video and see how you do. 13 through 19. Okay, I'd hope and expect that you get some of these right, especially here 13 through 16. 17 gets a little bit more interesting, only in that we've got to add and multiply radicals. And then 18 is a little bit more awkward because of the x expressions, and then 19 with the y expressions, but maybe you figured some of that out. Now, the next piece of here, this type of question, when you have consecutive sides of figures that are perpendicular, so all of these, everything you see here is made up of right angles, find the area of each figure. This is really just however you see to break up these items here to make smaller rectangles and bigger rectangles, then addition and subtraction is your way. Here's how I'm choosing to do number 20. I split this off into a skinny little triangle, a rectangle up top, a rectangle in the middle, and then another skinny little rectangle at the bottom. So this has a 6 times 1 is the area up here, 2 times 4 gets here. How did I get the 2? 6 minus 2 and 2 gets me 2. All those have to add up to equal 6. And then this is also a 6 by 1 6. So then 6 plus 8 plus 6 is 20 is where that came from. You could have done this a myriad of other ways. Well, not a myriad, but plenty of other ways. You can add, you can subtract, you can take bigger things and subtract smaller things. But see if you can break this into pieces. Like opportunity here would make a bigger one and then subtract the whole, if you will, or to chop this little piece off and add those areas up. But see if you can break these guys up and find the areas. Here's what I got. You can kind of see how I did it. If you chopped it up differently, that's fine. But see if you can figure out what you did wrong if you didn't get the same answers as me. I can tell you one thing that I did wrong is I did not put units squared. If you'll write that at the bottom of your page, always put whatever measurement it is in units squared. When we're talking area, that would be good. I'll have to deduct points on quizzes and tests if you don't. So rectangles and squares are special types of parallelograms, as are rhombuses. But parallelograms in general have the exact same area formula as what we just talked about. The area of a parallelogram is the base times the height. Now, here's the key. The height of every polygon that we're going to be talking about has to be involve an altitude, meaning it has to have a right angle. So the right angle is the key. Underneath where or over here to the side where it says parallelogram, please write right angle for height. You have to have a right angle for your height. So it doesn't matter where in this parallelogram it comes from. It can actually come from outside the parallelogram to find your height as well, but it's the distance from this height to the other, whether it's like the crane that's hanging out outside or what. So and it also doesn't matter which base you use. If you use this over here on the side as the base, and then what is the distance from it to the other side, as long as it's perpendicular, do you see how this goes perpendicular to the other side? As long as it's perpendicular, it doesn't matter which base or height that you use. Okay? This is kind of interesting to see. I copied this and pasted it and just flipped it up so that it was a little bit more vertical for you. This is the exact same thing. It looks just so looks better here because this is tilted. So example 1, find the area of a parallelogram with base 5 square root of 3 and corresponding height 4 square root of 3. Well, base times height is what we do. This is a simple product right here of those two values. Now this one gets a little bit more interesting because we get to choose which thing are we going to use for the base, the 8 or the 12. Well, which base has a perpendicular piece coming off of it? That would be this. We've already even marked this one with our height. So we need to calculate the length of this height. We'll use 12 for our base. How will we do that? Oh my goodness, look at there. There's a 30-degree angle. What did we learn about 30-degree angles? That's right. That's a 30, 60, 90 triangle. Hypotenuse, h is the short leg, so we divide by 2 to figure out that the height is 4. The base is 12, the height is 4. There is our area. So the actual area calculation is very simple. Sometimes we have to calculate the height. So, pause the video, try 3 through 6 parallelograms. I said 3 through 6, 1 through 6. So yeah, when it gives you the base and the height, that's totally easy. Like 3 and 4 in particular. 1 and 2 as well. On 5 and 6, you had to calculate the height. You may have found a slightly different way than I did, but to calculate the height, we need to chop off a right triangle. So if that helps you to figure out the height from here, try it again, or take another look at it. These are the answers. We'll talk more about it if you didn't get those answers. Where those answers come from are from these corresponding heights and that I have calculated over here now. Okay, the other type of parallelogram is a rhombus. A rhombus has 2 area formulas. One of them is, well, the parallelogram one. base times height, the rectangle one, base times height. So every parallelogram, you can use just base times height. That works for all 4 types of parallelograms, whether it's a rectangle, rhombus, or a square. But a rhombus also has an alternative one, where it's 1/2 of the diagonal times the diagonal. This comes from the right triangles that are created from this. I'll show you in class kind of why this formula works. But it's 1/2 of the length of one diagonal times the length of the other diagonal. So to find the area of this rhombus right here, I need to figure out the length of this diagonal and the length of this diagonal. Why do I have to do that? Because it doesn't give me, well, it gives me this base, but it doesn't give me any information to figure out the perpendicular height for that. So I'm going to use the diagonal version of this. It's easy to figure out that the length of this first diagonal is 8, but what about the second diagonal? Well, I'm going to use the right triangle formula. Okay, this side out here is hypotenuse, so we got 4. What is x? 3. We knew that. So what's the diagonal? The first diagonal is 8, the second diagonal is 6. So the diagonal formula, now if you have the 2 diagonals, this is pretty simple. It's 1/2 of 6 times 4, which ends up being 24 units squared. Now, question B has nothing to do with the diagonals. This is a rhombus, but you should tell right away it says nothing to do with rhombus. You treat this like the other parallelograms that we did. So if this is a rhombus, if this base is 8, well then every side is 8. We're going to use this for our height because there's the perpendicular piece. We got to go calculate h. Oh my goodness, there's a 60-degree angle. The hypotenuse of this 30, 60, 90 triangle is 8. That means the short side is 4, which means the height is 4 square root of 3. Now, we'll use the base times height formula, not the diagonal formula. 8 times 4 square root of 3 is 32 square root of 3 units squared. Okay, so try these rhombuses. These are the answers that I got. Again, if you got questions, we'll talk. All right, and finally, triangles. This is one that you should be familiar with already. 1/2 base times height. Now, I'm going to jump straight to a special case that we're going to see lots of times, and this is an isosceles triangle. We've been seeing this diagram a lot. This particular case always happens with isosceles triangles. It's a special case for it. But when there's an altitude, which the altitude forms the height of our isosceles triangle, well, then we have the right triangles here. The altitude of an isosceles right triangle splits up that base into 4 and 4. We can now use the Pythagorean theorem, that one's not a triple, to calculate what h is. H ends up equaling 2 square root of 21. Now we can use the 1/2 base times height formula. 1/2 of 8, which was our base, times 2 square root of 21. We get 8 square root of 21 units, or approximately 36.7 units squared. So it totally depends on what you're given. 7 and 8, I think it gives you what you need. Actually, 9 and 10 does too. But yeah, try these triangle ones. 11 through 14 use equilateral triangles, isosceles triangles, where you will have to calculate the length of the altitude. Give it a shot. All right, here's some answers. You can see how you did. We will talk about the methodology and answer questions next class. Parallelograms and triangles, most of that I hope you are already familiar with. We'll learn some more stuff, like you can see at the bottom of this screen, trapezoids in class. See you soon.